Hello, this is Wasey with Brazos River Air Conditioning. Today's video will be over manual JDNS calculations and how we do them and why we think they're important and what all goes into one. So this project is for another contractor. We do manual JDNS setups for ourselves as well as other contractors, and this one is a apartment building. It's a two-story. You can see over here I have different levels. Right now I have the second one hid just because you end up with a lot of rooms overlapping and everything. So we'll just deal with the first level to kind of show you what we got going. Obviously I've already drawn this one out. I've added in a few things, and we'll kind of go over all of them. Uh, to start any of these, you get a set of plans and you get the dimensions to your rooms and you draw out all your rooms. You add in your doors and windows, and then you start changing the things that affect your load. So let's start with windows. As you can see on a given window, I'll click the property and not the window. Let me get back to the window. Unlock this. Alright, so on our window we have a variety of different things that we can change, and all of these things affect how much heat will get in through any given window. Now this one, I've got the dimensions on your set of plans. There will be a thing called the window scale, and it'll lay out what the dimensions are and what type of windows they are and all of that stuff. This one does not have an overhang, so I have no to the shading. It is an operable window. It has vinyl. It's a vinyl window, no storm pane. It's clear low E. We know that there's a 1/4 inch gap and that it's an argon window. So fill all of that out, and I obviously set these settings up so that I could copy paste all of these windows as we went across. On top of that, you can set how much of a header there is over top of them. Often when I'm doing these for other contractors, I don't know that, but you can set it. If there's internal shading, like they're going to have drapes or blinds or any of that stuff, you add that in there. This one we're leaving at none because we don't know the exact design conditions. Again, insect screens, external sunshade, all of that stuff. So you set up your windows, you come down, you set up your doors, the type of the door and which direction it goes will make a difference on how much can get through. If you have wood, EPS, solid core, hollowed core, all of that stuff, if it's insulated, you set all of that up as you can. Now I would assume that this has a storm door, but it's not on the plan, so I don't have it put on here. Past that, you get your doors and windows set up. I've already got this set up for this building, but you set up your roof type. On this particular one, we have asphalt shingles. We have sheetrock. We have roof insulation R35. So with the new energy code in 2018, your roof insulation, I believe they're asking for R39. Now that's not being enforced in a lot of areas, but there are some areas where it is being enforced, and the location in which this one's being installed does have it. Our attic type is encapsulated. You can see here where the spray foam is on the inside of it, and then there's no insulation down on the actual ceiling. So you set all of that up. You go through and set up the slab and whether or not it's insulated, how the type of soil and all of that. as you have the information. You set up your type of window, your frame walls. So on our walls, we have vinyl siding. We have exterior board sheathing, and then we have our cavity insulation. Again, 2018 code is calling for R19. A lot of your standard stuff here in Texas is R15, but this one being where the energy code's being enforced, it has R19. So you include all of that stuff, and as you can see, you can do masonry walls, curtain walls, however you want to set it up. So we do all of that, and as I was talking, it occurred to me that this is our first story. So being that it's our first story, I have the ceiling type wrong, because there's a level up over the top of it. So we're going to select this. We're going to select all of our rooms, and we will change this to a ceiling partition because it's going to have another, you can see the floor above it. Again, you have to have certain information that sometimes I won't have. So we're going to use none here just because I don't know if they're carpet, tile, hardwood, and all of that changes how air passes from one to the other. They'll have R15 between the two. It's hard to get R19 into a 2x4 space, so almost the only way to do it is spray foam, and a lot of time they don't like using spray foam between floors because it doesn't kill the noise, so we'll use R15 because they'll probably be using bats. And then you need to know how thick the floor is. This one is going to be 12-inch trusses, so we set that, and that will set it for all of our different rooms. So now that we've got that set, we'll click off of it and get to our individual rooms. We're going to add things into each individual room that will change kind of how it's set up. So these are set up on 8-foot ceilings. So we set that already. We're going to be using air. Sometimes you'll have hydronic and stuff like that, and you can change that if you have it. We don't. And you can see I can change individual rooms, walls, ceilings, floors, all of that stuff if I need to. We're going to go ahead and click on the internal loads. Internal loads are really important. Basically, every person in that room puts off heat. Every TV, every appliance, all of this stuff goes into it and causes rooms. You can see it even accounts for plants if you want to get that detailed. We're not going to here because we don't know what's going in there, but if we were doing a greenhouse, that would become very important. So this is our living room, and you can see it accounts for electronic equipment and lights. And if we were doing a laundry room, we could account for the washer and dryer and all of that, and same with kitchen appliances. But we're setting the living room. Then we'll go to our bedroom, and we'll set it up. Again, ceiling height, all of that. On a lot of these, they don't have anything for the bedrooms, but I always include electronics if there's TVs drawn on the plans, and this one has TVs drawn on the plans in the bedroom, so we're going to add that in. And then you have to set a duct loss heat loss factor. Basically, they know that duct is not perfect, and we have insulation on them, but if it gets hot or cold enough in a given area, that duct can lose some of its heat or cooling to the outside area. So this screen allows us to go ahead and add in some things to set up for that, basically. So our ducts in the attic are going to be running in an encapsulated attic. It does not have for between a floor space, but being as we're basically in an insulated area that's closed off, we're going to leave that set to encapsulated attic. It asks for the type of shingles and all of that, and then actually, we're going to change this. Let's change this to, we'll just do a condition space. And then most of our, depending on how you want to set up your ductwork, you can change it to outside or trunk and branch. We're going to do center of the room here. We're going to assume that the ceiling is average. If you know the contractor well and you know the type of work they do and they overkill their ceiling, you can change that, but we're going to leave it. Discharge air temp. Most heat pumps are not going to hit this 100 degrees. However, with heat strips running with it, it will hit 100. So typically I'll leave that set around 100. This, you can set the percent that you think it's going to leak, an actual CFM, or what Energy Star rating is. We're going to leave it on MJ8, which is the latest code, basically. And then again, the return, we're going to change to the condition space. We're going to leave it radial. We're going to leave this at R6. By code, ductwork should be R8 insulation. However, in condition space, there's different places that will allow you to use R6, especially on returns. And just knowing how different contractors operate a lot of the time, R6 is a better bet. If it ends up being R8, then we just have a little less loss than what we've planned for. But anyways, we'll set all of that up. That gives us a duct heat loss gain factor. You can see, because we're in conditioned space, it's giving us a 0. Again, we're between floors and not in the actual conditioned space. So I'm going to go back and I'm going to change that back to encapsulated attic, just because we know we can lose some in that space. And again, they don't have a floor space. All right, so that sets up our bedroom. We'll go ahead, and obviously we had set up the kitchen and utility, and mechanical room and all of that stuff. But just for time, I'm gonna skip over that, and I'm gonna show you. So on our zone information, we're essentially trying to set up the conditions that people are going to run. A lot of houses, you just want to set this to kind of what the lowest and everything. If you know the customer's preferences, you can set it to where they would normally set their thermostat. I like to use the 70, 72, 50, which is essentially setting your temperature to 70 on a 100-degree day, 72 during the winter, and 50% relative humidity in the house. So you can see I changed the design temperatures on the heating to 70 instead of 72. To be honest, I didn't realize I had done that, but it works just as well. Now on room venting, we're probably not going to have any actual room venting. If you're doing a fresh air intake to every room, you would change that. We are going to set a central, because I do know that this is spray foam. I do know that it's a new build that's going to be really tight. It's important that you get fresh air into your homes when you're doing a tight build, because basically the air in your house can just circulate, and it's stagnant, it's dirty, it's full of humidity. This allows it to kind of change some of that out and keep your indoor air quality up. So we're going to set it up for that, and we're going to change this to a different standard just because it works better in this program, and your program may do differently, but that just works better on this one, or I've found that it does. Now you'll notice this only says 22, which seems fairly low, but we only have one bedroom set up. As I add more bedrooms and I add more people into different rooms, it will change that. The amount of water that a person breathes in and out every day would surprise you. I can't remember the numbers off my head, but it's several it's several gallons of water just breathing in and out, the amount of moisture that you breathe out or that you take back in. So the amount of fresh air that you need depends on the number of people in a home and the type of construction and all of that stuff. But we'll basically set all of that. And so you'll see here, it starts into the heat load, the load manual J basically. So it's taken into account that it's an envelope, that what it figures the infiltration would be given the type of siding and insulation and construction and everything that we set up. You can see the 0 on the room ventilation because they do not have it for fresh air in every room on this set of plans. Takes your subtotal, it takes into account your ducts, your central ventilation, if you have a humidifier in there, if you have any type of piping or excess blowers. And then you'll see this sensible heat ratio. That is not, 0.7 is not correct. There'll be a point in time in this heat load where I'll take into account the different BTUs and the sensible versus latent heat, and we'll figure that out. But we're just not that far on this one yet. So right now it's showing that it needs 0.7 tons in this area, and that'll likely adjust up by the time that we get everything added in. But so we'll come back here. So now we have our manual J. We don't have it all set up, but for the purposes of this video, it's set up. So the next step that we'll go through is we're bringing up a load meter here. And this is to show you, I ask people all the time if they know the orientation of the home. And most time the response I get is, what does it matter? It's the same building. The reason it matters is your windows will catch sunlight at different parts of the day depending on the orientation. So right now we have it set to north. If we change it to where this side is now your west side, you can see that changes it. If we change it to be the south side, that'll change your numbers again. So when we do these for other contractors, because we often don't know the orientation of the building, we include a multiple orientation summary. And this is why we do it, because on this home it doesn't change drastically. But if you had a building with 10 windows on one side and 0 windows on the other side, and you swap that orientation from north to south, it will make a big difference on what you're doing and what type of size you come up with. And then let's see, what else do we have here? We're going to set some load preferences. We know that on this particular building we're doing heat pumps, so it's air and air being supplied to cool and heat the home. We know our ceiling height, we set our duct loss. Basically this is the attic just refers to a preset that I have that basically sets it out for these settings, because I use this quite a bit, and that just says that I have an attic over the top basically. And then infiltration, so you can select different types of construction. Now I don't know the builder that we're doing this for, if they do tight, semi-tight, all of that. So we're just going to do average. We know it's a 2-story building. We know that there's 4 walls exposed to the outside. We know there's no fireplace. And right now it's showing that we have 660 square feet in apartment 1. And how much volume that apartment has, all of that will affect how much cooling we need. And then once we get through all of that, we will go down and we will set up static pressure settings. Now I'm going to have to look up some of these, but for right now I'll just enter some values that are similar. That way we know. So in a home, different things affect your airflow. It's blowing out, it's blowing through your coil, it's blowing through your heat exchanger on a furnace. it's going through your grill, through your filter. All of that stuff affects how the air flows. So we're going to set a value for our heat exchanger, our coil. We'll set our supply diffusers up. And again, I'm just making up these values. I know they're close to what normal stuff would be, but I've not looked any of this up yet. But so we set all those values so that when we get our ductwork set up, it's already accounted for in there. We'll go to our duct preferences. Changing from vinyl to metal, rectangular, round, all of that stuff will affect how our air flows and what the total CFM that volume will address. If you speed up your velocity and you're still on the same size of duct, the amount of cooling that you get out the other end will be affected. So you have to go through and set all of this stuff. Again, a lot of this is information that I have to look up or have on the plans. I use my own duct layouts. You can set this to being on a wire and x-axis, and it'll lay out your duct for you. But that's not how we're doing this one, I guess. You can select the type of elbows that you normally use, the type of boxes you normally use. All of this stuff will change how that ductwork gets laid out. All right, so once you get through all that stuff, now you're ready to look at equipment. So we're going to go to split equipment. We know that this is going to be a heat pump. We know that they're using electric strip for backups. Being an HVAC contractor and what we're doing, we don't care about the water heating. If you wanted to set up water heaters and stuff with this program, you could do that as well. All right, and we're going to come over to our air source heat pump page. Most manufacturers have a static pressure, a design static pressure of 0.5 or thereabouts. So that's what we're going to use here. We're going to let all of this fill in depending on our equipment. So we're going to go down and select equipment. And just so you know, just because this is 0.7 tons, we're probably not going to find something that works with manual S until we add in our other heat loads and stuff, but we'll give it a try. So as you can see, it's showing 5,000 to 8,000. We'll try to select for manual S. So you see it's only 6,000 to 8,000 minimum and max. So what manual S will do is, and a lot of the time I have to look up this information in the manufacturer specs and then apply it to the program and select a lot of this stuff myself. But manual S basically says we have this amount of load with a sensible heat ratio of X, and that means that our air conditioner has to put out X number of BTUs. Every 4-ton air conditioner is not 48,000 BTUs. 3-ton doesn't mean that it's 36,000 BTUs. As you can see here, this actually has some Goodman units that get 9,000. But you can see here, it reads as a 9,000. Its actual capacity is 10,000 on high stage and 64 on low stage. If you're working with a single stage unit, your manual S allows you, again, I'd have to look back at this, I guess, but I believe it's 10% of the actual load. If you step to 2-stage, you can go to 120% of the actual load. If you go to a variable speed unit, they'll allow you all the way up to 140% of the load, because they know that it can address it on the high end and even be more than what you need, so that if you have a 110-degree day, it can step up to there. But the important thing that they're worried about as far as code and manual S is that it's small enough to address humidity issues on the cooler days and your swing days. A lot of the time, your hot days, your peak load is only 15 to 20% of your year. which means that at 80% of your year, you do not need this much cooling. And if you put in too much cooling, like you go over the peak, then your unit has a tendency to short cycle. And along with the short cycling comes humidity problems, because if your unit is turning on and off and not running long enough to remove humidity from your air, it leaves it inside the house, and in a tight home, that especially spray foam homes, that humidity cannot leave. So basically, you end up with high humidity inside, causing issues with building materials such as doors, windows, cabinets, that type of stuff. Or you end up, it works its way down your walls and into your cavities and creates mold problems. So code isn't set up to make your equipment perform better. Code is set up for the public health. So with this manual S, or setting stuff for manual S, they don't really care if it's 105 outside and your system can't get to 70 degrees. They care about if it's 80 degrees outside and you're leaving 60% humidity inside and building mold. So that's why the manual S calculation has become energy code. Again, the energy code is not enforced everywhere, but at some point it probably will be. And whether or not it's enforced, it's a good idea to use it in your buildings, in your homes. So we would select, I'm just going to select one of these to keep the video moving here. And then I'll go back and adjust it once I have all of my stuff set up in it. So as you can see, I selected the equipment. It fed in what the different BTU ratings are, what the fan's running for CFMs, all of that type of stuff. So we'll apply it. We'll go OK. We'll go back to our drawing. We're going to let the duct show up. We're going to show the duct notation. And we're going to zoom in and try to work on just apartment 1. As you can see, it's got a return here. I'm going to set the return behind the unit. Oh, that's where we'll pull it out of. We're going to put one in the bedroom. And go over here. We're going to put another return grill out in the living room. And then we're going to pull these. Oh, this one's for the closet. 21 CFM really isn't enough to worry about, especially with return and everything coming back by there. Going out underneath the door will be enough. So we're going to delete this grill. And that'll add it into our mechanical room, where we are going to leave air going into our mechanical room. If the customer asks me to, I'll take it out of there. But anyways, I like to leave the air in there, because in this particular room we have a water heater, we have an air conditioner. They're both creating heat. We'll likely have AV equipment, your routers and all of that stuff. They all create heat. So I kind of want to cool this room as well. We're going to go ahead and we're going to drag this over here. We've got the bathroom and the utility room separated here. And, sorry, let me get these lined up real quick just to let I know where they're at. One thing I'm noticing, as you can tell, it's fun working with these small objects while holding a phone. But anyways, one thing I'm noticing is our bathroom and our utility room do not show any CFM values. So we're going to go back over here and we're going to see. They're included in the calculations. I don't know why they don't show CFM values right now. I'll have to figure that out after the video. But anyway, so we have our grill set up, or kind of where we want to set up our grills. And then we're going to go ahead and draw, and this customer specified kind of how their ductwork was going to run. We're going to change it slightly just for speed, but I'm going to bring a trunk line down. And once we connect it, it will begin calculating out what size of duct that we need. I don't know why this one on the end hasn't, but again, I've got time after this video, we'll address that. Probably just don't have it drug completely in the middle of the grill, but anyways, we'll take care of that in a minute. So we set up all of our supply ducts, and then our return ducts. And so for this one, they're all the same. They're all flex duct work, but say I wanted, see if we got this attached. Say we wanted to make this one metal duct. We can change the individual duct as well and change it to metal or sheet metal or duct liner or whatever we want to use. That way it takes into account excuse me, it takes into account all the different types of ducts, so we can set up each individual area different. But so anyways, we go and set all that out and obviously work out the kinks with these ones not connecting and all of that. It's likely due to the low load and them just not needing that much air. But once we add in all of our appliances and that stuff, that will likely change. But once we have that done, then we print you out a PDF. And in this PDF, I can include the loads. The sales and cost stuff is stuff that we don't provide. But if I wanted to, for my own personal use, I could have the cost of equipment in there and figure out the difference between gas and electric and all of that stuff. I'll give you a proposal form, the drawing of it, the different types of equipment, and verification that it does fit Manual S. I'll give you the duct layout and sizes, as well as the conditions that was designed for, so that you know that it's set up for flex duct or metal or whatever it's set up for. And again, ignore the sales one. And then there's an energy one to where it'll show all the different types of energy code and that it complies with and all of that stuff. But basically, I just realized why those ducts aren't working. As you see here, we've got a second unit in our second apartment here, and that should not be the case. So we're going to go over here to our multi-zone tree and see if we have all of the rooms for one in one. They are. Or wait, bathroom one, utility one. Bathroom one, utility one. They're both in there. So I don't know why that is coming up as a different system. I'll have to address that in a minute. But, well, I'll get it figured out before I send this out to them, obviously. But that's kind of the process that we go through. As you can see, there's a lot of information that needs to go into a heat load to get the proper heat load. And then once you get the proper heat load, you really need to stick to it. A lot of contractors and a lot of homeowners seem to think that the rule of thumb of 500 square feet or 400 square feet or whatever you've heard is correct. And our building practices have changed so much over the last 10 years that it is no longer viable to use that type of stuff. Now, some of these loads will come out in that range. However, some of these loads, like you can see on this one without adding the appliances and stuff, this thinks that it's less than a ton for 660 square feet and would probably be close to correct. Again, we've got to add in our washer, our dryer, our kitchen equipment, our hood for our exhaust on our kitchen, our bathroom exhaust. All of that stuff will add loads to it. But as you can see, it changes quite a bit, and we just need to make sure that we're trying to accommodate for all the different building practices. That way we're giving our customers the best system, the best airflow, and the best balance that we can, as well as keeping their indoor air quality at a higher level. If you let the humidity and the mold and all of that stuff get started in homes, it's bad for your customers, and it leads to lawsuits. So that's essentially why we're doing these, kind of how we do them, and all of that. But if you have questions, feel free to email us. My email is brazosriverac.com. You can find that on the website at brazosriverac.com, as well as on our Facebook page. I'm working on an Instagram page, our YouTube page, and all of that. You can send me plans. Please give me a text or a heads up that you're sending them. That way I don't miss them in the spam folder or something. If you send me plans, I'll prepare them, and essentially I send you an invoice and get paid, and then I send you a PDF of all of the stuff that we have. If you're a homeowner and you're wondering if your home is correctly sized, we will come to your home and check out your location and draw one of these for your home. We also do energy audits with blower door testing and duct blasting, to where we test for leaks on ductwork and all of that stuff. We'll evaluate your insulation, everything, while we're there, and basically come up and tell you if your system is oversized or undersized. If you've got a home that seems to keep pretty humid, or you have to turn the AC down to get the humidity out, there's a good chance that you're oversized, which, along with the efficiency and the indoor air quality, is hard on your equipment's lifespan. But as a homeowner, we can come into existing homes, new homes, all of that, and give it to you. If you have another AC contractor that you're using for your new home, we're still happy to provide this stuff. If they don't have the programs or the means to do it, or whatever, we still want you to get the best home that you can, and them having these as resources will help ensure that. So I guess just let us know if you need us, and that's kind of our manual JDNS calculations for you. I'll provide links to this video on our website, Facebook page, YouTube channel, all of that stuff. Comment, send us emails, send us text messages, whatever. Let me know what you thought, and anything that you think I missed that we should have included in this. I know that there's a whole lot more small stuff adding into these calculations. I just didn't feel like going through them all on the video. This gives you a good basic overview, but it is by no means a RightSoft class. So don't think that you can watch this video and that's all that you need to do and call it good. RightSoft does have training and stuff available. RightSoft is the software that I use for all of my heat loads. It's one of the only ACCA approved softwares in the country. It's by far the best in my opinion. They have excellent support, excellent training, and you can find them on their site. It's RightSoft, believe rightsoft.com with WRIGHT. But anyways, let me know what you thought.